Final question on exam 3. We're looking at the results from an experiment. And what this experiment tells us is that 15 liters of oxygen gas were produced. And during this experiment, it was found that this was supposed to be equivalent to 1 mole. Now, the temperature in the lab was measured to be 70 degrees, and the pressure was measured at 1 atmosphere. Does this allow us to determine if the experiment was done correctly? Now, there's a lot of ways that we could approach this problem. But what I'm going to do here is we've been given a volume, a number of moles, temperature, and a pressure. So that looks like we're dealing with an ideal gas law situation. And so what I'm going to use is I'm going to use these 4 determined values to calculate a value of R. So we can rearrange our ideal gas law by dividing by moles and dividing by temperature, and we find that R is equal to PV over NT. Now we're going to have to convert our temperature, which is given to us as 70 degrees Fahrenheit, into Kelvin. Everything else is in the units that we need it to be in. So if we go to our front page, we could find the equation for converting Fahrenheit to Celsius. So degrees Celsius is equal to 5/9 times degrees Fahrenheit minus 32. So here we can plug in our actual value, 70 degrees Fahrenheit. And when we calculate that, 70 minus 32 times 5/9 gives us 21.1 degrees Celsius plus 273.15 converts us to 294 Kelvin. And we should just keep this to 2 significant figures here. We can now plug all of these values in. We get R is equal to the pressure of 1 atmosphere times the volume of 15.0 liters divided by 1 mole times the temperature of 294 Kelvin. We'll now shift our answer down here. When we calculate R here, we get R is equal to 0.051 liters atmospheres over moles Kelvin. Now the known value of R is 0.08206 liters atmospheres over moles Kelvin. So clearly these 2 values of R, our experimentally determined value and the known value, are pretty far off from each other. And since those values don't match up very well, we can say with a fairly high degree of certainty that something during the experiment was not done correctly.